Afternoon, everyone. As Paul said, I'm Ken Bing. I'm Assistant Director of Maintenance at the University of Birmingham, and as of tomorrow, also West Midlands Regional Chair. So that leaves a vacancy for a deputy, so I'll be trying to catch people in the bar later. Our next speaker is Ian Knight. He's worked in the sector for 20-odd years, and he's a reader in the Welsh School of Architecture at Cardiff University and a director of K2N Limited. Ian didn't want me to go into a great lot of detail in the introduction because he'd like to sort of get the point across himself. But he did say if anybody got any questions or wanted to know any more about him, he's more than happy to answer them. So, hand you over to Ian.
Okay, thank you very much. I appreciate having lectured to students for very many years that an immediate lecture following on from another one is straight after lunch not a good place to be. So those of you who need a sleep, feel free to go ahead, but I'm hoping that there's a very comprehensive presentation which should be available to you afterwards, so if there's bits you want to skip through or not sure about, it should all be on the slides. So my way of doing this is I'm trying not to read through the slides. There are a lot of slides here, but it's to give you some indication of what this project is about and what we're trying to do for you. So where did this come from? Well, as was introduced, I've been sort of doing energy management sort of related activities for over 20 years, of engineering physics background. I've been in a school of architecture since 1987, teaching architects how to design buildings which are energy efficient. So I like to think that I've got a sort of reasonably rounded view of what works and doesn't work. And in particular, the bit which never really gets talked about, which are the bit to do with people. That's you, me, your finance director, the people you've got to convince that either it's worth spending time on energy efficiency or looking at why you're trying to do things in your buildings. So this project is going to be about 8 years long by the time it finishes. So it started off after the EPBD came out. It is funded by the European Commission and is the third project in a stream which looked at initially the impact that the EPBD was having on air conditioning inspections. So were people doing them? Were they saving energy? What did we find out? And what we found out was they were rubbish across Europe. We didn't have enough inspectors to do them. It was a pretty poor piece of legislation and compliance was poor. So this is across Europe. For instance, Slovenia were not prepared to charge any more than €100 for a complete inspection, by which you don't get somebody to the building. That was their idea of complying with the regulations. So from the speakers you've had earlier, the one this morning talked about Partel and Richard just now, they've all said things which are sensible and really decent advice, and I'd endorse an awful lot of what you've been told. But for me, it always keeps coming back to, when I want to do something or when I want to change something, what have we actually got? And is it doing okay? And most of energy efficiency that I see, and I talk to the European Commission, come down to individual levels. I've done best practice programme publications for the government, monitored buildings, all of these things. What nobody's been able to answer in all these years is the amount of energy I'm using reasonable for the activity I'm supporting? So it's not, is my energy going up or down, but I know that we've got air conditioning in this building and we've got ventilation in this building because of the activity that takes place. But we rarely relate what we do to the activities that are being served. So you'll get an office building, and Energy Consumption Guide 19 will give you a range of consumptions that are considered decent. And those figures came out of a whole load of extended energy surveys in 1992, before computers. The point is, even now, 20 years later, you'll still get figures coming out which show we haven't changed a great deal from those figures. The buildings still use about the same amount of energy. We've got an awful lot more stuff in them, but some of the stuff we do more efficiently. So on the face of it, if I'm in finance, I go, well, nothing's changed. 20 years of spending all this money on things, and we still use the same amount of energy. Why? And that is why the move towards zero energy buildings and the fact that we've now insulated the hell out of all our new buildings, and we realise there are problems with doing that, is we're moving into the holistic design period. It's no longer a single issue. So the original EPBD was driven by the insulation industry. So I went to the recast EPBD thing, was invited to Brussels, sat there in the chamber, and of the 5 people speaking, 2 were representing the insulation industry, the other 3 represented Europe. And you just think, well, who's setting the rules and why are the rules being set as they are? So this is all about trying to say this project is about giving you, or attempting to give you, as the energy managers, as the people who've probably got stories and lessons to tell us. I hear and wasn't aware that Keele was doing as well as it is with its energy management. That hasn't appeared anywhere. Why can't I see that? Why can't I see what Keele are doing? And the iServ project, which I'll be talking to you about, is an attempt to allow all of you who think you've got decent tales to tell, or things where you've done really well, you'd like them visible, you'd like to help the rest of you, to make those visible at a European level. So, we all know what energy use is, and it's the energy provided to each building and by whatever means. And again, one of the problems we get when we start to look specifically at HVAC, and I'll tell you why we're looking just at the HVAC side rather than the whole building as we go through the presentation. But the reason we're looking at this is people tend to define HVAC in terms of the major items of equipment. So whether it's the chillers or the boilers and the energy use in those, all the side stuff which is important for delivery, whether it's the fan coils in the room, which all have a little 120-watt motor in them, those things tend to get forgotten. They're not included in the energy use of that system because they're fed from somewhere else. They're fed off the lighting circuit. You can't monitor them, so they don't really exist. Well, we know they exist, and we know in their entirety they're important. So as we move towards near or zero energy buildings, those balance of plant, those small bits of equipment that are being used and continually running, they become more and more important in attempting to get down to those much lower energy use figures. So we have to revisit the way in which we account for the energy use in buildings. You can't just do it off profiles. You can't just do it off before and after. So HVAC is the bit that you've really got control of as estates managers. And it's one of the things that the Commission are focusing on. And one of the reasons they're focusing on it is this. For the European Union as a whole, HVAC, so air conditioning, fans, pumps, circulators, space hot water heating, just the electricity use alone accounts for over 11% of all the electricity that we use in the European Union. If we look at what that means in terms of cost and GDP, the EU GDP in 2007, which was the latest figures that I've got for this overall usage, we had a GDP of just over 13.5 billion euros. The electricity costs alone are 10 to 20% of that. So with the HVAC being sort of approximately 10%, if we can start to make savings just at that level, 10%, it's not huge, and lots of studies have shown that's available. We're saving 15 to 30 billion euros, it's worth having, or 0.1 to 0.2% of the GDP. So when you start to look at it like that, it's not huge. But the European Union want to do it for energy security purposes, not right at this moment in time, not costs. But since, obviously, the EPBD has started, costs have gone through the roof. And now it's starting to become really important from a cost point of view for Europe as well. So this is just trying to sort of put in some sort of context. And of course, in all of that, nothing to do with fossil fuel use, which HVAC systems account for sort of 90% of most usage within the building sector. A little bit about it, for those of you who don't know, there are things I've learned with dealing with the European Commission, one of which is how few people actually set policy. So this Part L comes from the transposition. That's the UK government takes EPBD and says for our local circumstances in the UK, we will implement the requirements of the EPBD in this way. So we get that through Part L. There was a recast of the EPBD in 2011, not sure if you're aware of it, but from October 2013 onwards, there will be a new version of Part L which reflects those changes in the original EPBD. The EPBD arose because the market did not deliver. So we wanted energy efficiency in buildings. There was no driver for it. Nobody was doing it. There's always other things to spend money on. Small part of your costs. So there has to be legislation to do this. And Richard was dead right when he said that compliance is probably the only thing that drives most of our organisations to do things up until very recently. The very recently is all of a sudden the energy and other costs have become a large part of our estate. And quite a few people here, I would imagine, are looking at energy from a very different point of view now, which is it's actually, every pound I save is the equivalent of an extra 2 or 3 students or something through the door. There's sort of a market and a commercial imperative now to doing this. The implementation of the EPBD you're all aware of, but we are heading towards, there's likely to be another revision of the EPBD somewhere around 2015, 2016, as the final push towards trying to meet the end of 2018 figures, which the public sector have to meet, that you will no longer be able to procure buildings which are not near zero energy at that point. So it's not very far away, but nobody knows how to get there. So in a few years, we've got to try and find this information. So within the EPBD, HVAC systems referred to as technical systems, and that near zero energy building target means that our HVAC systems are likely to be very different in only 5 or 6 years' time from what we do now. So it would be good if we could start picking up good practice now. So who decides them? Pressure bodies, industry lobbying, academia. These are the people who are setting our targets. Rarely, however, do you, as the end users, get involved in setting those targets. So if I was to say to you, what do you think you can actually achieve in a building? You would probably come up with something different to what the legislators would do. And we therefore, without really understanding what's being delivered in buildings, because we don't know what we're delivering in the buildings, we don't know what they're being used for, so everything's a little bit uncertain. We end up with these sort of unusual issues where one of the recent parts of the Nat Vent of the Part L meant that we struggled to build naturally ventilated buildings because this notional building didn't allow us to achieve the percentage increases because naturally ventilated buildings are already pretty good. So we couldn't get them. So we start building mechanical buildings. The very first 2002 regs, when we first started to put all the meters in that were required, how many of you have got all your sort of heating, ventilation, air conditioning, lighting, small power, separately metered and recording back in your buildings from post-2002? Few hands. Yeah. And I'd imagine for most of you, trying to get those to work when they were installed were not the easiest thing in the entire world. So we've got this sort of weird sort of situation we're going through where we're learning about energy efficiency on the hoof. And a lot of this regulation is written on the hoof. It's whoever shouts loudest and comes up with a good idea. Just in case you thought it was done through some sort of sensible approach, it's not. So this project, I'll finally get around to it, we went back, I ran a previous project before this which actually went out and did inspections, air conditioning inspections in buildings, and compared that to what sort of quarter-hourly monitoring was telling us about those air conditioning systems to see whether the inspections found what was available. And it didn't. So as a result of that, the recast EPBD that has just happened was changed to allow now an alternative approach to compliance. This you won't see yet, and this will come in about 3-4 years' time, I would think. But the alternative approach that iServ is testing, trialling, demonstrating, and hopefully getting into a lot of the European states is that if we can give you benchmarks which you can show that you are meeting, then you are deemed to have complied. So rather than going down the route of having to have inspections, having to have people come and check what you're doing, you are able to demonstrate it yourself. And you will be involved in setting the targets from what you're achieving. So, one of the ways that I got to sell this to the Commission was to say we want to reduce the legislative burden i.e. the red tape, on people who are already doing things well. So if you've already spent a lot of time and effort in metering your buildings, you've got all this information coming back and you're frustrated because nobody seems to acknowledge that effort that's gone in, they'll just come and give you something else, like the CRC. You say, well, yeah, we don't care what you're doing, just have something else that you've got to do. This should try and get rid of some of that legislation. So Harmonac was the prior project to this one, harmonising air conditioning systems. You've got to have a peculiar acronym, and that's peculiar enough. So, you know, we've done 42 odd case studies around Europe, which was very enlightening in many ways. You know, the fact that we use more air conditioning energy per square metre here than they do in Greece, because we heat and cool simultaneously. So all our systems are fighting each other. But this is a brand new headquarter office building for a major law firm in London, just showing some of the metering that came back. And we saw this sort of arrangement a lot. This was allegedly a fully metered building, and we couldn't account for nearly a third of the electricity use in the building because of post-base build installations from the client, mainly HVAC, mainly servers, additional air conditioning systems they didn't need, additional chillers they didn't need, but that sort of added into this. But we are now at a stage where almost all of you, I would imagine, know about AMR. You've probably got them or are installing them in your buildings. How can we start to use this information properly? So we got a bit of data back out of that project on in-use energy consumption in HVAC components. So how much energy was a pump, a fan, a chiller, an air handling unit using when supplying a particular activity? And we can start to use that for the benchmarks that we're hoping to produce. So the crux of the issue, we actually monitored 2 London headquarter office buildings, one of which, as I say, was brand new, all the latest stuff, variable speed drives, low fresh air rates, chilled beams, low energy daylight link lighting, and the other one was the old Sun headquarter building in Fleet Street, which had been refurbished in '88. It still had the fans that they were using to ventilate the main atrium, which is where the printing press for the Sun newspaper was, and it was just an office building now. So these fans were hugely oversized, didn't have any decent controls or variable speed drives on them, and it used exactly the same amount of energy as our brand new building, which was meant to be low energy. So what went wrong? Well, there were a couple of things which immediately you go in, you could see what they'd done wrong with the design of the system, which is a little bit of sort of creep as the systems have been designed. But effectively, you know, you've got experts designing this system for you, and someone somewhere didn't realise that actually if you've got chill beams in, they need water at 14, so deciding that one set of chillers would do those and the fan coils, which needed water at 6, was not a good idea if you wanted to get the energy efficiency out of your chilled beams. So you have to take the chilled water and heat it back up to 14 to stick through your chilled beams. Doesn't work overly well from an energy efficiency point of view, but it's the entirety of things. Individually, you look at the bits and say they've got all the components you need, this should be low energy, but it doesn't work like that. So poor design choices get locked into HVAC system energy performance for decades. So we've got to try and show what works in practice. So this was just, you know, the prospects for automatic monitoring. What are we likely to get? So rather than inspecting, rather than sending people around, which is time consuming, if you are monitoring regularly, we showed that sort of savings of, you know, another 67% further savings are likely to open up to you. Most of which are due with control, but they are there, and, you know, this was seen across various parts of Europe, not just UK. And we also found that for just the air conditioning systems that we were looking at, the average saving was 35 to 40% of the electrical energy use. Now, actually, the chiller, or the air conditioning part of that, generally isn't the largest consumer in your system. It's the pumps or the air handling units. But it's still significant, and the other bits, the delivery side of it, also had major savings that could be made. So I've said already, what Harmonac did was led to a rewrite to allow automatic monitoring, control and feedback approaches as an alternative to inspection. So we're setting those up now. Sibs are involved in this project, Reva are involved in this project. We've got some major developers, all who are trying to get this to work so that we can look at this alternative approach. the transfer of emphasis is from reacting, as Richard said earlier, don't just, okay, new legislation, what am I going to do now? It's about looking forward. So it's about actively demonstrating. It's us setting, this is what actually the best I can do for conditioning a lecture theatre is demonstrated at Keele University. They are using X kilowatt hours per square metre for a 400 seat or a so many square metre auditorium. Those things, if you know where they are, and we could demonstrate them, we can all find out what was done to make it work. And we know that that is achievable then with real people. Because people will bugger up every sort of beautifully laid scheme, particularly as we go to low energy. And I'll explain why now. So, this is the thing that seems to be forgotten. Buildings are for activities. We only build a building to do something in them. But when you concentrate on energy use of its own, we can tend to mess up that thing that we built the building for in the first place. And we've all probably got very high energy consuming facilities somewhere on our campuses, you know, whether it's medical facilities, whether it's data centres. All of those things actually need to use energy. So we're not going to get a near zero energy building for those activities. So where do we set that boundary when we get to 2019? So if you look at it, energy efficiency should always be bound by the requirements of the activity that it is serving. So if we produce the wrong environment for the activity, it's counterproductive to what we're trying to do as an organisation. And it doesn't matter whether that's a university or an office or whatever. So we can only, by logic, we can only properly evaluate whether something is energy efficient when we put it in the context of the activity that it serves. So we want to know how much energy is it appropriate to use for a given activity. That's really the question we've come to now. The role of the occupant in this, there's loads of studies, and most of you will probably have seen similar things when you try to do it yourself. Up to 30% of the electricity use in the sorts of buildings that we look after is influenced by the occupants. So you've got to engage with them somehow. So you can't just do it sat in front of your BMS or just talking to yourselves as estates. You've got to engage the people who are doing it. Some of you are doing it and some of you are doing it really well. And I've seen some great examples as I've been around sort of various parts of the UK where initiatives have worked really well. And you know, there's loads of information out there that you do, and there's various lists that you subscribe to where you talk to each other. But getting that visible to the legislators is what we can't yet do. So responsibility, accountability and engagement are the things we want to do. I apologise, it's an equation. I realise you're not here to learn anything, but I couldn't resist because it's actually quite simple what we're trying to do when we get towards the much lower energy buildings. So we've got, you're all aware of this, you know, the energy we use in the buildings is the interaction between our internal gains, what comes in through the windows from solar, what we lose or gain through the walls, lose or gain through ventilation, stuff that we store in the fabric, so it's sort of any sort of storage is going on in there or losses or gains from that, latent energy, if you've got swimming pools or anything with a particularly high latent load, and then the mechanical energy we use to balance it all. Those are our services. New and zero energy buildings, and we now know this as we're starting to build more of them, and the passive house has got a problem because of this, so there's lots of feedback now from white passive houses. The people who occupy them, you know, that awkward bit where you put somebody in it and they don't actually like the way you designed your building so they can't open the window. That's one of the problems they're getting back is we can design them in theory, but people want to use them differently. So when we start to strip out all of those terms, for modern, heavily insulated buildings, the conduction losses or gains become negligible. So do the energy that we are storing in the fabric, to a large extent in most of them, not all of them, there will be some that don't. And usually the latent gains are negligible as well. So we're only left with our internal gains and our ventilation losses and gains. So that's where our problem is. We now need, with our newer buildings, to be balancing those two. And when you have an intermittent occupancy or an occupancy that you can't predict, it is very difficult to get your ventilation, heating and cooling to work well. And that's the new era that we are moving into when we come to design our services. So a number of you will have come across demand control ventilation. It's getting to get an awful lot of attention now, as it has become clear that this is where the savings will come from next. It's an integral part of getting to near zero energy buildings, but it's also got a really big role to play in some of the existing buildings that we have. So when we assign responsibility, our building energy use splits logically into two areas. The energy that we use and is consumed by the occupants. So if you just stuck a building up, an old building where we had no services, there'd be a certain amount of energy used by the occupants to do their activities. The services we put in then are to provide the conditions that we say those activities should take place within. So plus or minus temperature, whatever relative humidities you want, however much fresh air you think. That's what our services are doing. The graph down the bottom there is a study I did, and it's part of the Part L in the CIBSE guide, which just shows how our internal heat gains vary by the density of occupancy. You all know this. You stick more people in a room, you get more heat. So if we are then to judge how well our air conditioning or ventilation systems are working, surely we need to know how many people we have in the room to say whether it's efficient or not. How do you get that information? So there's a number of things which feed in, and if we are going to reach near zero energy buildings, we need to know about. The second energy use, so we split it from, we need to know what the occupants are consuming, lighting and small power, and then the consequent energy use of those activities, which are the services to make those activities viable. So what we're arguing for, what this project is arguing for, is a reality check of what it is actually possible to achieve. So before we rush headlong to saying we're just continually going to keep reducing the targets all the time, but we're not actually going to tell you how to do it, we're just going to make it your requirement to do it. Well, across the whole of Europe, I've probably only seen 2 or 3 buildings, low energy buildings, that are actually comfortable to be in for the activities that they were doing. I've probably seen about another 100 which are rubbish. Okay? They're low energy, they don't use anything, and the occupants hate them. So it's, we've got to learn those lessons now before you suddenly start procuring a whole load of things on best advice from consultants. I could come and consult to you tomorrow and I wouldn't have the slightest idea, but I'll quite happily come and consult to you because you'll pay me lots of money to do it. And then I have no handover responsibility after it goes, and you live with the consequences of that. So we've got to try and get this back to show me somewhere where they've done it, so I can go and see it, and we can show that this works in practice with the occupants. So we will be producing, out of iServ, out of this new project, a first version of in-use benchmarks. So we've already put together from all the literature that's out there, from various VDI documents, CIBSE documents, stuff that's scattered around Europe and the USA, what we think components and things ought to consume. There's also this thing that nobody actually knows what a near zero energy building is yet. We all know at 2019 we have to meet it, but there is no formal definition. So I sit on the CIBSE technical committee, and we met earlier this summer just to try and put together a definition of those buildings. And this is what's formally proposed. And it's a whole load of jargon, and the bit I like, which I still don't get it, is why technically unreasonable achievable energy use of greater than 0 kilowatt hours. Where's the upper limit to that? 350 kilowatt hours per square metre, is that acceptable? Anyhow, apparently it works from a legal point of view. But the bit that's interesting here is the reasonably achievable and the by comparison with national energy use benchmarks or anything else that a member state might consider reasonable. CIBSE is a full partner in this project, and it will be, for those of you who are CIBSE members, it will be using this information to produce professional guidance for you on what you should be achieving for various activities and HVAC components from about 2014 onwards. Just for information for those of you who are really nerdy and want to have a look, that's what has been proposed by the European sort of umbrella body for all the building service engineers. It's still not defined yet, but it gives you some idea of where they think the boundaries might lie in these definitions of a near zero energy building. Are they feasible? German housing energy, it's always the Germans, okay? They do everything, so they're miles ahead of us. They can make things work in a way that we can't. I still haven't figured it out yet. From 1980s onwards to 2015, you can see the reductions in energy use they've been getting in the domestic sector. So they have some demonstration sort of high-tech buildings which are currently positive energy buildings. They are generating more electricity and energy than they consume over the year, but their standard sort of well-built systems are heading down towards sort of 30 kilowatt hours per metre squared by 2015, so only 3 years away. So yes, domestically it's possible. Non-domestically, we don't know. Number of different sort of things just to look at. BIM, you've had a lecture on BIM. That's inevitably how we're going to organise information in the future. It's coming, and it's going to be really useful in many aspects of facilities management, not least in the sort of proposal that I'm talking about, where you take knowledge of your estate and the activities and then compare it with what you're using. But modelling is not yet a reliable way of predicting energy use. We've got loads of buildings which have been modelled to within an inch of their life and perform nowhere near what they were modelled to do. We know that, we know it's a problem, which is why we've got to go through this reality check again to improve our prediction techniques as much as they can be. It may be that the confounding factor of putting people in buildings, particularly as we get to low energy, is so big that you can't actually model to any reasonable accuracy what that effect is going to be. All we can do is make them as robust as possible. So a bit of the data out of iServ will be used to inform our modelling techniques, see if there's fudge factors and things you can put in to do that. So this is the process itself. It's a €3.3 million project. It's the largest European Commission project ever funded because they know it's important and they want it to work. And there's three sort of things behind the philosophy. The one we know, you can't manage what you don't measure. Everybody knows that one. You can't control what you don't understand. Now, I'd like to think that all of you here know what all your air conditioning systems are made of, what models they are, where they're located, how to find them, what they're serving, and how they work. My experience is that probably 90% of you don't. You might know some of it, but it's an inherited sort of law that's passed down from father to son within the generations of your energy managers, and somebody knows where that peculiar fan was and which door you had to go through to find it, or even where the meters are located. So one of the things we're doing is with SIBSI and everywhere else, we've set up a framework for you recording this information in a way that links it all together. It's a simple spreadsheet, but it gives you a way of connecting everything, just individual parts, connect them all together as you know what you have. And the fun of it, data should lead to decisions, not graphs. Beloved of all energy management systems is the ability to produce a wonderful graph which shows your profile changing over time. And the vast majority of the time you have no idea why the change has happened. But you have the graph to show you a change has happened. It's gone up or it's gone down. If it's gone down, you always claim it as how well you're doing. If it's gone up, it's somebody else's fault, and it's somebody's changed the use of the building. We need to get beyond that. So to ways that you know what is going on and why it's going on. So we've got a number of goals. Part of this is going into the set standards, so it's part of the frameworks and things that will be coming along. First set of benchmarks, highlight the solutions, allow you to take responsibility for long-term targets and things, and a bit of reward for good behaviour. What are we seeing? Electricity savings between 5 to 60% per system are anticipated from the tests we've done before. The 60% will almost undoubtedly be controlled. So systems running when they shouldn't be. They're really easy pickings, we just need to show you what's happening and the data will show you that. Electricity savings on average are 5 to 15% in just on the HVAC systems. And we're also showing that because you're continually doing it, the inspection is a one-off, you may not be inspecting again for another 7 years. Because it's continuous, you get feedback, we maintain those savings. The past energy benchmarks that we used have been vague. I was involved in setting a number of them for schools, sports and leisure, and there was one other, I can't remember. And nothing's really moved on from them because the government has never supported the revisiting of those benchmarks. But they were vague because at the time we couldn't collect much data. There were very few meters. Now we have thousands of meters. What we don't know is what to do with the information. So, as I showed previously, the benchmark system should relate energy use to the activity undertaken, along with an indicator over the overall size of the activity. Now, usually that might be floor area, but it might be face length of the fume cupboard, it might be number of meals you're serving in a canteen. The appropriate benchmark in some activities will need to be determined. Practical benchmarks. So it's this thing, legislation friendly. Can we give you benchmarks that are easy to understand? The legislator can write a very simple piece of legislation which just relates, you will meet these figures, here's how you will meet it, and work on it that way. So the procedure is, we've already said we should split into two areas. So we need benchmark ranges for the individual HVAC components, lighting and small power. Just to show you who's involved in this, we've got Camfil, Skanska, Swagon, Riva, Sibsey as sort of the external manufacturers, trade bodies, professional bodies, and then we've got a number of people from around Europe who are all mainly HVAC and engineering experts from various universities. So the way we collect data, we've got a spreadsheet, which is free. You can download it now off the website if you want to start looking at how that might work. It describes spaces, areas, activities, links them together, and then we just need to then collect the data from you to put in a form that we can start to generate these benchmarks. And that will be over the next, the project finishes May 2014, so we've got about 18 months where we're trying to collect this data now to start setting these benchmarks. I'm just going to stop for a second there, because in my experience now, I set up a project where I say, okay, right, I'll sort of demonstrate the basics of you and outline some things for you, and we get the basic set of benchmarks out. And then the industry will take it up and run with it, and we'll get better benchmarks out and everything else. The reality is, these benchmarks will come out and they'll probably stay for a long time, because nobody else will ever do a study again, or it'll become commercially sensitive. So it is important for all of us, and for me as well running the project, that the benchmarks we get out are reasonable and reflect what you do. So the more, those of you who've got decently metered or monitored estates and you've got the data already, I'd really like you to consider strongly participating in this project if you can do it. So what does it involve? What's the setup? You basically describe the meters in the building, including their physical locations, so you know where to find them again. You describe each of the HVAC components in the building, including their physical location. So this is just a straight cataloguing. Each room, most of you will have a space utilization database or something similar. Room name, square meterage, and the choice of an activity. What is the main activity to take place in that room? We then take the incoming meter, connect it through our meters, connect them to the spaces they serve, connect the meters to the chillers, and the HVAC components to the systems they serve. So there might be one chiller serving a couple of different systems, and connect those systems to the rooms. All that is done within the spreadsheet. So we allow you to set everything up and then say, okay, this serves these rooms, this serves this area. So you've got this sort of then the collective memory about that nobody quite knows where everything is. You've put it down, you've done one exercise to get it together, and then you've got it ad infinitum until you want to change what's connected to what. So that's there, that's, as I say, that's free. SIBS are endorsing that as a way of collecting information for AC inspections as well, and that's likely to feed through into the next bit. This is what the spreadsheet actually looks like. It's just a series of cells, drop-down boxes, and then you add rows in as you've got more things, whether it's spaces or components or whatever. So the overview of the whole process is we take that initial spreadsheet, which is a one-off thing, and probably the most difficult part, to just collate that. We then collect your data, hopefully 15 minutes or less time frequency. That all goes up to a database. We give you an email address to send it to. It all gets put in, along with, if you've got costs and tariffs, we'll take those as well, and we'll give you information back in terms of cost per space, cost per activity, cost per component. So you start to see where your money's going, and you start to have a discussion with your finance director about, actually this looks like there might be some useful savings from here. You get out of that then reports on how things are going from a benchmark point of view. There's a thing called ECOs, which is energy conservation opportunities, and we analyse your data against a whole series of things that might potentially go on, including best benchmark for what you're doing, and give you numerical and cost values for those. So you can see where your best opportunities are from a cost point of view. You can take that straight to your finance director, or you can go to cost those up and say, okay, this now gives me the information I need to make decisions. The benchmarks just come from collecting that data. You've told us where everything serves. So within the system, we are able to pull out from your information, everybody else's information, what people are consuming for a given end-use activity with various bits of HVAC components. Doesn't matter if you've only got one or two done, because we've got a sufficiently large number. We'll be collecting up to 1,600 systems across Europe. We will get a decent, coherent range, statistically fairly robust range of consumptions that you ought to be assuming by an activity. So, by a component, sorry. The makeup of a benchmark for an activity might be something like this. So, this is, the top one is that's the installed capacities. So, watts per square metre, we ask you, what have you got in, what can you potentially use, what's the installed load. And then, from the data, we say what we're actually consuming. So, we will then data mine all of this over the course of the project to give you a whole lot of things back, such as, generally it might be that the fans consume 10% of their installed capacity. So you've got rules of thumb that you can work with when starting to look at where you might want to save money. You will get benchmarks, or the intention is to get benchmarks at an annual energy use, monthly consumptions per square metre, and the one that I'm most excited about is the average power consumption, because we're looking at 15-minute intervals. We'll actually be able to say lots of people are working around 3 to 5 watts per square metre for this particular component. You seem to be up around 10 or 15 in use. So that in-use bit is the bit that generally gets missed. With this data, we should be able to give you that detail. So the different benchmarks, and again, because they're from real buildings around Europe, they carry a huge amount of weight, and I am hoping, therefore, that by putting these out, we may be able to avoid some of the worst excesses of some of the legislation, which I know is coming, about what you have to try and meet. So by saying, yeah, this is reality, this is what can be achieved right now, if you're doing this, I think you may find it as an alternative, something that works much better for you as an organisation. This is my life. This is just, there are 7,900 different HVAC benchmarks by end-use activity, which is down the side for air handling, chillers, humidifiers. This is just the front top left-hand corner of the sheet. And we're putting those together. They automatically will then calculate benchmarks for your systems. So from the information you give us, you will get a bespoke benchmark for your HVAC system with the components that you have for the activities you serve. So it's not a generalization, it's specific to your building and your activities. From all of this, we will be able to give you guidance on what works in practice. So we don't care what technology is doing. You can have a duct cycling around in a car park, as far as I'm concerned. If it produces low energy use, we'll say the lowest energy use was produced by the duct cycling around in the car park. So we don't care how you go about doing it. So if you've got something innovative, it's not precluded because people don't understand it. So it means manufacturers have a much faster route to market as well. So if there's new stuff coming out, we should pick this up within months rather than 5-10 years before it becomes established. We also, this thing about the energy conservation opportunities, the more we get, the more we see, the more we can give you automatic feedback on what your profiles appear to be suggesting. So a few reports about what you might see. This is an example of a whole system. So in this one, we've taken the building, we've amalgamated all the benchmarks for each of the individual activities by area to give you an overall benchmark by component for each of your HVAC system. We've added up your whole HVAC system. We say this particular HVAC system, which is actually in Keele's Mackenzie House in Cardiff, air handling unit 1 and 2 are the main air handling units for the building, but there's a number of smaller systems as well within the building. So we've just taken 2 main air handling units. Ignore the benchmarks for now, please, because they're still, I put them there just to show you what it would look like. Don't panic. But this shows you what's actually being consumed through the meters, so that's the blue line, and the green, yellow and red show how you're doing relative to the benchmark ranges that we've got underneath it. So the benchmarks aren't a single figure, they're a range of consumptions that people are achieving. And we're just going to set those benchmark ranges probably at the 25th and 75th quartile, or 75% quartile at the moment. We can also do it too for individual HVAC components. Because we know what the benchmark should be, if you're metering it, we will be able to say, compared to your benchmark, these parts of your components are working well, here's what you seem to be consuming more than you should. So again, it gets down to the detail, and is using your sub-meters sensibly to give you unambiguous feedback. As regards to somebody saying, I've got 15,000 sub-meters, nobody has time to look at them. We'll look at them, we'll produce a report for you, and they can be exception reports as well. We've talked about eco, so I'm not going to go into that again. You can also do the standard stuff. So if you are wedded to just looking at figures, here's you can get the data directly back out as Excel spreadsheets. So from the system, you just say, I want to look at these meters over this period of time. It'll give you it as a spreadsheet. You can do your own graphs. That's what you want to do. 15-minute interval means you can do carpet plots. So this will also come out of the system. So this is how a set of chillers are again working in Mackenzie House, where Keith doesn't allow anybody to have chilling, even when they actually need it. Thanks, Keith. I'm glad I don't work in your building. But you can see where the chiller's coming off. You can see the weekends fairly clearly, and this the colours represent 10% intervals up to the maximum. So the white spot, which occurs about the 4th day in, each vertical row is a day. Each square represents 15 minutes in that day.
I'll go on leave that day.
You're always on leave. I know you can do it remotely because they complain about you. And each one of those colours, so the brighter the colours, the more energy you're consuming. So you get an immediate visual of what's going on. And here we can see that actually, all joking apart, the building's fairly well controlled, and it goes off at a set time when everybody leaves, so it's not running on into the evening. We also get this individual calculation of, by an individual component, for the area and activity served, we get figures as what's using. They feed our benchmarks. That's what we will be feeding back to you. We will take that information, turn it into part of the benchmarking. We can also, if you put in your tariffs, we can give you a cost by activity. Now I know that for a lot of people, the ability to say, this activity is costing me so much, or I want to rent a space out, this is how much it's costing, would be a really useful piece of information for your finance people. We're doing this because we are desperate for you to use the system, and we'll give you anything that will get you on. So I feel like I'm prostituting myself here, but anything you want, we will try and give you within reason from the data. So if you take the reports, we're responsible for all the database. We can write the reports, we've got the people to do it. So in this particular one, this is showing us how much we're paying in pounds of electricity for catering, store cupboards, external spaces, the high density IT suite. The big green area is the main office and consulting areas, which I would hope, because that's the biggest usage of that building. But there's a cost, and that's per month. You can do it per year, rolling annual figures, whatever you want. Similarly, we could take each individual space in that building, and I don't know, it's about 300 or 400, and show you where you're spending your money. So the one on the far left, that's room 211, which I presume is the big office on the second floor. And that's what we're spending on each space per month. So that information comes out as well. So just to wrap it all up, because I'm up to time. This is working with the Commission. It is likely to find its way into legislation. It's probably 4 or 5 years away, but if you are setting things up now with a view to look into the future, with a view to look into near zero energy buildings, try and set your systems up so that you are able to link together activities, components, energy use, so that they make some sense, and you're able then to tap into these new ways that are going to come. Participation. As I've said, we'd all like you to participate. There's a website at the very end, which is on the slide. You can just go to there, download the spreadsheet from there. We can give you some help initially to start with in terms of telling you what to do. We can't do it for you, unless you want to pay us, in which case, of course. But the reality is the project's free. We don't, the Commission, despite what everybody thinks, getting money out of the Commission to do anything is like getting blood out of a stone. and they are paranoid that nobody will find us doing things we should not be doing, so they won't give us money to come and look at anyone else. So this bit will be on if you wish to participate. Direct end user benefits, the Commission have said that you can use the IEE logo, which has the European Commission on it, to say you are participating in the project, so we can put logos and stuff on it. So as part of corporate social responsibility, as part of you trying to show to your directors or whoever might be interested that you are participating in setting the benchmarks, all of that will be claimed. We will stick logos and things up on the website for you. Anything you want out of it that you think I'd quite like to be able to show this to my director or whatever, we will try and accommodate those requests within reason. The idea is we're halfway in, the database has just got up and running now, we're collecting data, we're collecting the buildings now. I would think within 4 to 6 months we will have the comprehensive stuff, but we'll start giving you feedback and reports as we start to generate them, as we start to understand them. So, and some of what we're hoping is you will give us feedback on those to say, actually, this isn't quite the way I need it, or I don't quite understand what we're showing here. So you should get that automatically. The idea is that you send us the data, we will generate you a set of standard reports that you said you want. You don't need to go to the website to do it. But if you want to look at the data, you'll have a log on and a password, and you can just go and use it to pull out any data that you've sent us that you want to know for other reasons. Supervision we've talked about. We've talked about how to participate. There's a website address there. And I don't think there's much else. 2014, blah, blah, blah. You can see I'm trying to put this together and keep repeating myself, so I apologise. Oh yeah, last one. We're looking for around 100 to 200 HVAC systems, so there is a limit to how many systems we can take around the EU. I'm running the project, so I'd like the UK to get first dibs for those who are interested, so I'm not thinking about it to you now. It's being pushed, or Subsidy should be starting to push it in, if not this month's journal, the next journal after that, and other people will choose to come into it. So we've got about 30 signed up at present, so if you've got a well-monitored estate, it should actually benefit you, even if you just look at a couple of buildings, to look at what this might mean to you. So summary, it's the only large-scale open approach. It's free, it's independent, nobody's sponsoring this other than the Commission. We're blind to manufacturing, we don't care who it is. It should allow you to fully understand the system, maybe for the first time. And as I've said before, the long game is that if you can get me the data, I can make sure that I can make the case at the European level and then at the UK level. I'm already talking to Paul Apple, who's the building control officer, who's in charge of the building control officer in large parts of London. And that influences the rest of the UK about what the building control officers will be prepared to accept. So the more you can give me, the more in case I have to make on your behalf, which is what this is all about. And that's it. There is no time for questions, and none of you want to ask one anyway, which is why I've used up all the time, because it's not embarrassing to stand here while you don't ask me the question. I'm sure we're all going to go for a cup of coffee. If any of you want to ask me a question, I would suggest maybe we do it over coffee. Okay? Can I go? Not yet.
I think that was an excellent talk in behalf of the Association of University Engineers to present you with a token of our appreciation.
Thank you very much.
I'd like to... like to encourage colleagues to really do get involved with the project, because it'll only be as good as the information that's used as part of it. Obviously that concludes the talks for now. The next one starts at 4:15, depending on which one you're going to, so if everybody could be there sort of promptly at 4:15, and don't forget to fill in the Tom Bradley forms as well. Thank you.